Welcome to Green Dolphin Science and another deep dive.
Yeah.
Today, we're digging into a spice that's probably in your kitchen right now, turmeric.
Oh, yeah. It's everywhere. Famous for that amazing color, its unique flavor, and its, long history in traditional medicine like Ayurveda and cooking across Asia.
Exactly. Nepali food, South Asian dishes, Middle Eastern cooking, and it's got that active compound curcumin that people are really interested in for health reasons. Anti-inflammatory, antioxidant.
For sure. It's become this huge wellness trend, too, not just for cooking, but as a supplement.
Right. But here's the issue we're diving into today. With that popularity comes a dark side. There are growing concerns about adulteration.
Specifically, adulteration with some really nasty stuff, heavy metals like lead and chromium.
Yeah. So we're looking at a recent research study that actually tested commercial turmeric samples.
And our mission is to unpack this study, figure out what they found about these heavy metals, why it's happening, and what it really means for public health and, well, for you.
Okay, let's start with this term adulteration. What does that actually mean in the context of turmeric?
Well, simply put, adulteration is adding something to a food that shouldn't be there. It could be something spoiled or just filler, or in this case, something actively harmful like synthetic chemicals.
And for turmeric, the big worry is lead chromate.
Yes, that's emerged as a major problem, lead chromate.
Lead chromate? I mean, why? Why put that in turmeric?
It's purely for looks. Lead chromate is this incredibly vibrant yellow pigment. It looks almost exactly like the best quality turmeric.
Ah, so they use it to make maybe lower grade or duller turmeric look brighter, more appealing?
Precisely, to enhance the color. But the huge issue is that lead chromate contains two highly toxic heavy metals. Lead, P, and chromium, Cr.
Right, PBP, and if that's mixed into the powder?
It ends up in your food and then in your body. Consuming turmeric adulterated like this directly increases the levels of these toxic metals in your system.
Which leads to, well, serious health problems, I imagine.
Exactly, significant health implications.
Okay, so tell us about this specific study. How did they approach investigating this? Where did they get their samples?
So the main goal was straightforward. Measure the actual concentration of lead and chromium in turmeric powders being sold commercially. They collected samples in Nepal from local markets, bigger department stores, and supermarkets in cities like Itahari and Biratnagar.
And why those cities specifically?
Well, they're near the border with India, so they're major points where goods, including spices, enter the country. It gives a decent idea of what's circulating in the market.
Makes sense. What kind of samples did they get?
They got a real mix, 7 different samples in total. Raw, dried turmeric fingers, like the whole root, unpackaged powder sold loose in the market, plus several branded powders, some popular national Nepalese brands like Bansuri and RKM, and also internationally recognized brands like Goldie and Tata Samapan.
So a good cross-section, from raw ingredients to packaged goods people buy regularly.
Right. The idea was to compare across these different types and see where the problem might lie.
And the testing method. How did they find out what was inside?
They used standard lab procedures. First, they had to digest the samples, basically dissolve them completely to get the metals out. They used something called aqua regia acid digestion for that. It's a very strong acid mix.
Okay, dissolve it down, then what?
Then they analyzed the resulting liquid using a technique called atomic absorption spectroscopy, AAS.
Okay, give us the simple version. What does it do?
Basically, you shine a very specific light through the sample. Different metal atoms absorb light at unique wavelengths. AAS measures how much light gets absorbed at the specific wavelength for lead and how much for chromium.
So it can tell you exactly how much lead and chromium is there, even tiny amounts.
Exactly, down to very low concentrations. They also checked other things like moisture content and pH, just as general quality indicators.
And crucial comparison points, they checked against safety limits, right?
Yes. Absolutely critical. They compared their results to the permissible limits set by the World Health Organization, the WHO, and also Nepal's own Department of Food Technology and Quality Control, the DFTQC.
What are those limits?
For lead, the WHO recommends a maximum limit of 0.1 parts per million, ppm. The DFTQC in Nepal actually aims for nil detection, meaning ideally it shouldn't be detectable at all. For chromium, both WHO and DFTQC set the limit higher at less than 6.0 ppm.
Okay, ppm parts per million. So really tiny amounts we're talking about, but obviously significant for toxic metals.
Very tiny, yes. 0.1 ppm is like 1 drop in about 13 gallons. But with toxins like lead, even these trace amounts add up and matter a lot.
Got it. All right, the moment of truth. What did the study actually find about lead levels in these turmeric samples?
This is where it gets quite concerning. Of the 7 samples they tested, 5 out of 7 had lead levels above that WHO acceptable limit of 0.1 ppm.
Wow, 5 out of 7. So a majority of the samples they tested failed the WHO standard for lead.
That's right. It wasn't just one bad batch. Sample A, which was the raw, dried turmeric, had the highest level by quite a margin, 0.50 ppm.
0.50. That's 5 times the WHO limit.
Exactly, 5 times. And others were high too. Sample B, the loose powder, was 0.24 ppm. Samples C, E, and G, which included some branded products, were also over the limit, ranging up to 0.45 ppm.
So it wasn't just the raw or loose stuff. Even some packaged brands had excessive lead.
Yes, that's what this particular study found in its sample set. These consistently high levels across different types of samples strongly suggest, intentional adulteration is likely happening, probably with lead chromate. The paper even mentions other studies that found lead and chromium in a ratio consistent with lead chromate in heavily contaminated samples.
Were any samples okay regarding lead? Below the limit?
Yes, thankfully. 2 samples, D and F, which were the RKM and Goldie brands in this specific test, had lead levels below the detection limit, less than 0.01 ppm.
Okay, so it is possible to find turmeric that meets the safety standards. That's good to know.
Definitely. It shows that lead contamination isn't inevitable.
What about chromium then? Were the levels also high?
For chromium, the picture is different. All 7 samples tested within the permissible limit of 6 ppm, set by both WHO and DFTQC.
All of them. So no samples exceeded the chromium limit.
Correct. Sample A, the one with the highest lead, also had the most chromium at 3.31 ppm, but even that is well below the 6 ppm limit. The others were lower, between about 1.5 and 2.6 ppm.
Okay, so based on total chromium levels, things looked acceptable. But you mentioned lead chromate earlier.
Yes, and that's a really important point that source brings up. Chromium isn't just one thing. There's trivalent chromium, Cr3, which is actually an essential nutrient we need in trace amounts.
Right, the good chromium.
But then there's hexavalent chromium, Cre, that is the toxic form, a known carcinogen, and it's the form present in lead chromate.
Ah, and this study measured.
It measured total chromium. It didn't distinguish between the essential Cre and the toxic CrDBA. So while the total amount was below the limit, we don't know from this study how much of it might have been the dangerous hexavalent form from adulteration.
Got it. So even if the total CR is below 6 ppm, the presence of any CR, especially if it came from lead chromate, is still a potential red flag because it could include the toxic hexavalent form.
Precisely. It adds a layer of concern even though the total number passed the regulatory threshold.
Okay, this is sobering stuff. Let's translate these numbers, ppm, lead, chromium, into real-world impact. Why should you, listening right now, be worried about this? What are the health implications?
This is really the crux of it. Lead is nasty stuff. It's a powerful neurotoxin, and the real danger is that it builds up in your body over time. It's cumulative.
So it doesn't just pass through?
No. Chronic exposure, even to low levels like those found in some of these turmeric samples, can lead to serious long-term problems.
Yeah.
In children, it's particularly devastating. It can cause irreversible cognitive impairment, learning disabilities, developmental delays.
Irreversible.
Yes. And in adults, it damages the nervous system, can harm organs like the kidneys, contributes to high blood pressure, and can cause reproductive problems. And get this, the body can actually mistake lead for calcium.
What? Mistake it for calcium?
Yeah, so it can get incorporated into your bones and teeth and stay there for decades, slowly leaching back out into your bloodstream over time.
That's deeply unsettling, stored in your bones.
Okay.
And what about the toxic chromium, the hexavalent form?
Chronic ingestion of hexavalent chromium, CrGI, is linked to gastrointestinal problems like ulcers and stomach upset and definitely kidney damage. But the biggest concern is that it's classified as a human carcinogen.
Carcinogen, meaning it causes cancer.
It increases the risk, yes. Specifically linked to lung and stomach cancers when ingested over time. The source is clear. Hexavalent chromium is carcinogenic, nephrotoxic, meaning toxic to kidneys, and tumorigenic. It can promote tumor growth.
And you mentioned children are especially vulnerable.
Absolutely. Their bodies absorb lead more easily than adults, and their brains and nervous systems are still developing, making them incredibly susceptible to its toxic effects. The study references other research projecting really alarming potential increases in child blood lead levels in regions with high turmeric use, like maybe 10 times the CDC's level of concern in some areas. That kind of exposure is tied to things like lower IQ, ADHD, behavioral issues, lifelong impacts.
Just Devastating potential consequences from a common spice.
It really is. Pregnant women are another high-risk group. Exposure is linked to increased risk of miscarriage, premature birth, low birth weight. Studies in places like Bangladesh have directly connected pregnant women's blood lead levels to turmeric consumption.
The study also mentioned this isn't just an issue in South Asia, right? It pops up elsewhere.
That's true. Lead exposure from imported spices, including turmeric, has been identified as a health concern in immigrant communities in the U.S., for instance. They mentioned Bangladeshi American children specifically.
But the overall burden must be much higher where it's eaten daily by almost everyone.
Exactly. While it's a concern everywhere it's consumed if adulterated, the potential public health impact is vastly greater in countries like India, Nepal, Bangladesh, where turmeric is a staple food used in large quantities almost every single day by nearly the entire population. The sheer scale of exposure is different.
And does income level play a part?
Sadly, yes. Studies suggest that people in lower-income households, particularly women and children, might be more likely to buy cheaper, unpackaged, or less regulated turmeric, which unfortunately carries a higher risk of being adulterated. So they face disproportionate exposure.
So the long view is grim. Cumulative effects leading to lifelong problems for kids and chronic diseases like high blood pressure, kidney failure, and cancer risk for adults.
That's the potential long-term outcome of chronic exposure, yes.
Okay. Shifting slightly, the study also looked at moisture and pH, right, as general quality checks.
Yes, they did. These aren't about toxic adulterants, but more about overall product quality, shelf stability, and safety from things like spoilage.
What did they find with moisture content?
Well, the DFT-QC limit in Nepal is under 12% moisture. Sample A, the raw-dried turmeric, was way over at 18.22%, and sample B, the loose powder, was also too high at 13.83%.
Why is high moisture bad in a spice? Seems counterintuitive.
High moisture creates a perfect breeding ground for microbes, mold, bacteria. It makes the spice spoil faster, lose its flavor and potency, and just reduces the overall shelf life and safety.
Okay, so A and B failed on moisture. What about the others?
The other 5 samples, the branded ones, were all within the acceptable moisture limit.
And pH, was that an issue?
No, pH looked good across the board. The ideal range for stability and safety in turmeric is around 4.5 to 7.5. All the samples tested found nicely within that, between 5.6 and 6.1.
So pH was fine, indicating good stability, but moisture was a problem for the raw and unpackaged samples. It really highlights potential issues at different stages: drying, processing, storage, and then the deliberate adulteration we focused on.
Exactly. Contamination or quality issues can creep in at multiple points.
So given all this, the lead contamination, the health risks, the quality issues, what can actually be done, what did this study recommend? Let's start with us, the consumers.
Okay, so for you listening, the first step recommended is awareness. Just knowing this is a potential issue is important, especially if you see turmeric that looks almost unnaturally bright yellow or comes from an unknown source.
Be a skeptical shopper. What else?
If they become available and reliable, consider using rapid test kits. Some are being developed that can give you a quick color change indication if heavy metals might be present.
Testing at home. Interesting.
Yeah.
Any other buying tips?
Yes, look for certifications. Certified organic turmeric, like USDA organic or India organic seals, often involve stricter testing, including for heavy metals. It's generally a safer bet.
Organic certification as a proxy for safety testing. Makes sense.
Also, try to buy from reputable, well-known brands that have clear quality control measures in place. They have more incentive to ensure their product is safe.
So brand reputation can matter here.
It can. And conversely, the recommendation is generally to avoid unpackaged, loose turmeric from completely unverified sellers, especially if that super bright color raises a red flag.
What about buying the whole root, the rhizome?
That can be a good option if you can get it from a trusted source, like a local farmer you know, or a verified market. Then you can dry and grind it yourself. Less opportunity for adulteration that way.
More work, but potentially safer. And advocating.
Yes, consumer voices matter. Supporting calls for regulators to conduct more routine testing of spices for heavy metals and pushing for affordable, reliable home test kits to become widely accessible.
Okay, those are practical steps for individuals. What about the bigger picture? Systemic changes recommended by the study.
On a broader level, the study stressed the need for public health authorities to run awareness campaigns. Make sure people understand the risks. Then, critically, much stricter enforcement by food safety regulators, like the DFTQC in Nepal, more frequent, rigorous testing of products on the market.
And real consequences for breaking the rules.
Absolutely. Stronger penalties for companies or individuals caught intentionally adulterating food with toxic substances like lead chromate make the risk not worth the reward.
Deterrence. Makes sense. Did they suggest alternatives for the color issue?
Yes, and this is key. They pointed out that there are safe, viable alternatives to lead chromate for color enhancement. Producers could use concentrated extracts from high-quality turmeric itself, more curcumin, natural food colorings like annatto, or even approved food-grade synthetic yellow dyes.
So safer options exist and are feasible.
The source suggests they are feasible and economically viable, yes. It's about encouraging or mandating their use instead of toxic cheats.
Right. Anything else on the broader level?
Continued research is needed, especially to understand contamination levels in smaller, informal markets, and to improve detection methods, and ongoing guidance for consumers on limiting exposure, especially from potentially risky sources.
It's definitely a complex problem needing action on multiple fronts: consumers, industry, regulators. Now, we should also acknowledge no study is perfect. What were the limitations of this particular one?
Good point. It's important for context. First, the sample size was quite small, just 7 samples, and it was geographically limited to 2 cities in Nepal. So you can't necessarily generalize these exact findings globally, though it highlights a known issue.
Okay, small scale. What else?
We touched on this, but measuring total chromium instead of speciating it, figuring out how much was toxic Ki versus essential Ci, limits how precisely you can assess the chromium risk.
Right, the total versus toxic form issue.
Also, it's just a snapshot in time, one set of tests. It doesn't show variation over seasons or between different batches from the same brand over time.
No long-term tracking.
Exactly. And they didn't perform source tracking to pinpoint exactly where the contamination occurred for each sample. Was it the farm, the processor, a specific adulterator? Knowing the source is crucial for targeted solutions.
Makes sense. Any other limitations?
While they didn't directly measure health impacts like testing blood lead levels in people who consumed these specific turmeric batches, the health risks discussed are based on existing toxicology knowledge. The focus was also mainly on commercially packaged or market samples, potentially missing issues in very local, small-scale production and use. And like any test, there's a detection limit. They couldn't measure lead below 0.01 ppm.
In cooking, does that change anything?
That's another unknown from this study. They didn't assess if cooking affects the bioavailability, basically, how much of the lead or chromium your body actually absorbs from the cooked food versus the raw powder.
Okay, so lots of nuances and areas for more research, but the core findings about lead are still quite stark.
Absolutely. The limitations don't negate the main finding of concerning lead levels in a majority of the tested samples, pointing to a real problem.
So wrapping up this deep dive, what's the single most important thing you want our listeners to take away?
I think the key takeaway is this. Turmeric is amazing, culturally important, potentially beneficial, but this study underscores a very real and serious public health risk from contamination, especially with lead. And it seems largely driven by intentional, illegal adulteration just to make the product look better.
And that underscores the power and importance of being informed, making careful choices, and supporting calls for better safety measures.
Exactly. Your choices as a consumer looking for certifications, questioning unusually bright products, supporting reliable brands coupled with robust regulation, testing, and penalties are really vital to tackle this and protect everyone, especially kids.
It certainly makes you look at that golden spice jar a bit differently. It leaves me thinking, turmeric has such deep traditional roots and massive global appeal now. How do we navigate that? How do we honor the cultural practices and culinary joy while demanding safety in these incredibly complex, often global supply chains? And maybe more pointedly, how much can our individual awareness or simple choices in the supermarket really influence and help solve such a widespread and potentially dangerous food safety problem like the one this study highlights?
Definitely food for thought. Important questions to keep asking.
Indeed. Thanks for joining us on this deep dive into the world of turmeric.